guys, welcome back to this video. Today we'll be doing indices and surds. Okay, all the key concepts of indices and surds. Again, I'll bring it to you in one video. And this is a pretty short chapter. This is a pretty easy chapter. So this should actually even take less than 30 minutes, hopefully. Okay, all the very basic things is what this chapter is about. And I'm not going to cover all of those in detail because they are very basic. You will probably learn them in normal maths, or you might have already learned them before in, year 7, year 8, year 9 as well. So we won't cover those in too much detail, but I'll still just mention it broadly. Okay. So my name is Shamo Gupta, and let's start. Okay. Now, indices and surds, right? Indices is basically to do with powers of numbers. There are these things called laws of indices. For example, if you have 2 to the power 3 times 2 to the power 2, these powers add up to become 2 to the power 5. This is a law of index. This is a law of index. Okay, if it becomes plural, it becomes law of indices. Okay, this is a very common sense law. 2 to the power 3 times 2 to the power 2. It can be written as 2 times 2 times 2 times 2 times 2. So now there are 5 2's actually. So that's why you can write it as 2 to the power 5. Then there's one for division, 2 to the power 5. Divide 2 to the power 2. In this case, it subtracts. Okay, this is again a common sense law. It's 2 times 2 times 2 times 2 times 2. Divide by 2 times 2. Two of them cancel, you're left with 3. Okay, so then you're left with 2 to the power 3. There are so many laws like this, which you'll have to learn in your normal maths. And they are useful for your studies in Add Maths. Okay, that's that's a lot of the basics which you have to learn about indices. Okay, I'll just show you guys a summary which will have all of those laws which you need to know. Okay, and I'm not going to cover all of them in great detail. So I'm just going to show you I'm just going to get a screenshot for you which will show you the summary of all the laws you need to know. And I will be very honest with you. This is it's wrong to call them laws. They're almost very common sense laws. Okay, this is a short chapter, so okay, I'll try to explain most of the laws if I can. Well, rule number 1 and rule number 2 I've just explained. They call it a rule. It's actually just common sense. Okay, if you think about it, it's literally just common sense. So this one we've done, this one we've done. A to the power n times a power n. Okay, suppose you have 2 to the power 3 squared. Or let's take 2 to the power 3 to the power 4 actually. This is the same as writing 2 to the power 3 times 2 to the power 3 times 2 to the power 3 times 2 to the power 3. So this is 2 cubed times 2 cubed times 2 cubed times 2 cubed. That's 2 to the power 12. So you're adding 3 4 times. That's why you can just say that they directly multiply to become 2 to the power 12. Okay, that's another law. Okay, let's quickly erase this. Then what's the next law? A to the power n times b to the power n is ab to the power n. Okay, again, this is just, suppose you have 3 squared times 2 squared. You could write it as, this is actually what, 9 times 4, which is 36, or you could write it as 3 times 2 squared, which will also give you 36. Okay, then all the other laws are similar to that, a to the power negative n, blah, 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 blah. Okay, the last law is particularly important. Some students might get confused in this last law. Okay, a to the power m over n. This is how I like to think of it. I like to think of it as a power 1 over n to the power m. A power 1 over n from the previous law, it will be the nth root of a to the power m. The nth root of a power m. This is this version of it. Okay, they also have another version of it. You'll be like, how did they get this? Well, it's almost the same thing. Instead of taking it as a power 1 over n to the power m, you could think about it as a power m to the power 1 over n. So it becomes the nth root of a power m. Okay, so you'll notice that these two are actually the same thing. By the way, this will be n over here. Nth root of 1 over n. Okay. Why is it n over here and not 1 over n? Because if it's power 1 over n, it will be n. Suppose it's square root. The square is actually power 1 over 2. Cube root is power 1 over 3. You write it as cube root. Okay, these are the conventions we've been dealing with in our studies all along in secondary school of maths. Okay, so these are the basic laws which you need to know, and you won't be asked these because these are extremely simple, but you will be asked. You might be given some questions where you will need some of these laws. Okay, you will need some of these laws, but it won't directly be asked to you because of its simplicity. Okay, now there are very basic basic questions which can arrive out of these. Like, you might be asked to solve simultaneous equations using indices, or you might be asked to solve some more complicated equations using indices. And for all of that, I recommend you practice just past paper questions and questions in a textbook. Okay, but there's one particular concept which I would like to highlight, is that sometimes they might give you something like 5 power 2x um, plus 3 power x minus 10 equals to 0. Okay, or let's take a simpler example to start with. Okay, let's take okay, you might be asked to solve something like this. Okay, so here we use an actually very key concept, that 2 to the power 2x using the law of indices can be written as 2 to the power x squared. Now, how does that help us? You get 2 to the power x squared here plus 2 power x minus 15 equals to 0. Then we use something very smart. We use a very smart idea. Let 2 to the power x equals to s. You can use any number, but because we are Shamo, I'm using s, and because my name is Shamet, I'm using s. So if you think about it, if 2 power x is the same as s, I can write this as s squared plus 2 minus 15 equals to 0. Oh, this is just quadratics. This is basic quadratics. I can solve this. X plus 5, s minus 3 equals to 0. So I get s equals to negative 5 and s equals to 3. And what was s? S was 2 power x. So 2 power x was equal to negative 5 and 2 power x was equal to 3. Now I can solve from x here. You will need something called logarithms for this, which you will learn later on. Okay, so you don't need to worry about it if you can't get it now. Okay, if you're learning it right now and you practice some questions, you will be given better values. For example, 2 power x equals to 4. So then you can solve x equals to 2 directly. If you get 2 power x equals to 3, you will need something called logarithms. And then x will actually be log base 2 3, which you don't need to worry about if you have not done logarithms yet. But if you're revising and you're watching this video, then yes, you need to be able to know this, how to solve these using logarithms. Okay, yeah, that's a lot about indices. Then we come to surds. Surds are stuff like square root of 4. Well, not really. Square root of 4 can be written as 2. Okay, so things like square root of 3, square root of 5, square root of 7, all these are called surds because they go on and on and on and on. I guess that's the reason. You can go into the definition of surds or something, but this is the idea, that square root of 2, square root of 5, square root of 12 also. But square root of 9 is not a surd. Okay, it has to be an irrational number. So square root of 9, square root of 4, square root of 16, square root of 36, those are not surds. Okay, but sometimes you should know that you can write surds in, you can simplify surds. For example, something like square root of 20 can actually be written as 2 square root of 5 or 2 surd 5. They call it surd 5, 2 surd 5. How can this be done? Surd 20 or square root of 20 is the same as 4 times 5. This can be written as square root of 4 times square root of 5. This is one of the properties which we'll learn. This becomes 2 square root of 5. Okay, they are actually properties of square roots. For example, square root of a times square root of b is equal to square root of ab. Square root of a divide square root of b is equal to square root of a divided by square root of b, which is equal to square root of a over b, which is equal to square root of a over b. Okay, these are just a few, very, very few. There's like 1 or 2 more of this which you'll have to remember, and if you remember this, it'll sort out all your basics of algebra. Okay, it'll sort out all your basics of algebra. And there's one more, and this one is almost common sense. Okay, square root of a times square root of a is a. This is almost common sense because square root of 7 times square root of 7 is 7. Or if you think about it, 7 times 7 is 49. Whenever you multiply two square roots of a number. For example, 49 is a number. When you multiply its square root twice, it always gives you that number. When you multiply its square root twice, it gives you the number. What is a square root? Square root is a number which multiplied by itself gives you a number. So for example, if I want the square root of 80, it's basically any number. So suppose the square root of 80 is x. It means x multiplied by itself will give you 80. Any number multiplied by itself to give you that number is the square root. So for example, if 49 is a number, the square root is 7. It means if you multiply 7 with itself, so 7 with 7, you get 49. So if the square root of a is how we're writing it, surd a, that means surd a multiplied by itself should give you a. Okay, even in terms of indices, it makes sense because this is like a power 1 over 2 times a power 1 over 2, and 1 over 2 plus 1 over 2 is 1. So it becomes a power 1. Okay, that's all some properties of surds which you need to know, and you might be asked to solve some equations. You might be asked to solve some equations in which you need to know some of these properties. Now, there's this one thing called rationalization. Rationalization means suppose you have 2 over square root of 5. Okay, like remember how many times sometimes you have 2 over negative 4. Is there anything wrong in having 2 over negative 4? No, but you usually write it as negative 2 over 4 and then you simplify it as negative 1 over 2. Do you write it as 1 over negative 2? Trust me, they're the same thing, but we tend to write it as negative 1 over 2. That's the more simplified form. Okay, so 2 over square root of 5, there's nothing wrong in it, but we tend to make it so that all the square roots are in the numerator instead of the denominator. Like how for negatives, we try to get the negative in the numerator and not the denominator, right? So in this case, we try to get the square roots in the numerator and not the denominator. How do we do that? Well, there's this idea, and this is a genius idea, and unfortunately, I have not invented this, so don't credit me, but it's quite a genius idea. Not a genius, it's almost common sense after a while. You multiply this by 1 over 1. You multiply this by 1 over 1, you get 2 over square root of 5. Nothing's changed. Yes, nothing's changed. So what do? You use a similar approach, but be a bit smarter. You can multiply this with square root of 5 over square root of 5. This is still 1 over 1. Any number divided by any number is just 1. This is still 1 over 1. You'll be like, Shamo, this is root 5 over root 5. No, the point is this is just 1. Anything multiplied by 1 is itself, right? 2 over square root of 5 multiplied by 1 over 1 or multiplied by 1 is itself. So 2 over square root of 5 multiplied by 1 is also 2 over square root of 5. But now you can simplify the left hand side. Let's use a different color. I zoomed in accidentally. Let's go back. So let's use a different color. I can write it as 2 times square root of 5 over square root of 5 times square root of 5, which is 5. This way, I've literally rationalized the denominator. They say I've rationalized the denominator. Okay. There's one more case where you'll need to do rationalization. Okay, and that's in cases suppose you have 2 over 1 plus square root of 2. Oh, now the denominator has one number with no surd and one number with a surd. So 1 plus surd 2. Now how will you do this? Okay. Now here's the technique. You use a similar technique, but you have to be careful of what you choose as to be your something over something. Like you're choosing surd 5 over surd 5. So it's a little bit careful you have to be on what you choose. Suppose I choose 1 plus surd 2 over 1 plus surd 2. I will get 2 multiplied by 1 plus surd 2 over, this is almost like 1 plus, this is not almost, this is 1 plus surd 2 squared. So this becomes 2 plus 2 root 2 if I expand the numerator. The denominator becomes 1 plus 2 root 2 plus 2, which is 2 plus 2 root 2 over 3 plus 2 root 2. Doesn't help, does it? My denominator still has a surd. Okay, if you can try many combinations and most of them, the denominator will still have a surd. So what is the solution? So suppose again you have 2 over 1 plus surd 2. The perfect thing to multiply it is with 1 minus square root of 2 over 1 minus square root of 2. Now, Shamit, what's special about this? Because there's this identity which you should have learned in your year 9 or in your whatever, in your normal maths. A plus B multiplied by A minus B is actually A square. Then you can simplify, A square, then this will be minus AB plus AB plus AB plus B square. This minus AB and this plus AB just cancel out. So you're left with a square plus b square. You should remember this identity. Okay, you should remember this identity. A plus b, a minus b is a square plus b square. You should remember this identity. It'll be helpful for you everywhere. So what this does is, so in the numerator again, I'll have 2 over 1 minus square root of 2. In the denominator, it's 1 plus square root of 2, 1 minus square root of 2. So a is equal to 1 and b is equal to square root of 2. This can be written as 2 minus 2 root 2 over a square plus b square. So a is 1, so 1 square plus b square. So plus b square plus root 2 square. This is 2 minus 2 root 2 over 1 plus 2, which is 2 minus 2 root 2 over 3. You can see now we have a 3 only. Shaman, does this work every time? Yes, this works every time. Shaman, why does this work every time? Because see, a plus b, a minus b, these numbers, they are non-square root of number. They are non-square rooted numbers, right? 1 and 1, they are non-square rooted numbers. They will also give you a non-square rooted number. These two are square rooted numbers, surds. But when two surds of the same magnitude, so like square root of 2 and negative square root of 2, both have a square root of 2 in them, right? And it's a square plus b square. So square root of 2 square. So square root of 2 multiplied by square root of 2, it will also give you a non-square root number. It will give you 2. Now it'll be like, Shami, 2 is square root of 4. That's still a non-square, that's still a square root of number. But you can express it as you can write it as 2, right? You can write it as 2, right? That's exact, right? So 1 plus root 2 over 1 minus root 2, that's the way to go, because this thing a square plus b square in the denominator. Make sure that both a square and b square together. So a square individually becomes a integer, or it becomes a simple number like a exact number, a non-square root of number, and b square also becomes a non-square root number. So a square plus b square also becomes a non-square root number. So your denominator does not have a square root. Okay, so it's rationalized. Okay, that's the basic idea of square roots. I've basically summarized the whole chapter 3 for you. I suggest you practice a lot of questions on this, because the concept of this is easy. Sometimes the questions can be a little bit hard. Okay, sometimes the questions can be a little bit hard. With practice, this is probably one of the easiest chapters. Okay, I'll say this is the this is probably one of the easiest chapters in your whole of Add Maths, which is why this class was also short, this lecture was also short. Okay, but you should never underestimate it, because it can have harder variations. So practice as many questions as you can. Just like I said, a little bit of questions from your textbook, get a little bit of confidence. Okay, and then you're good to go. Okay, there's just this one particular type of question which I have seen a lot. Okay, it's one particular type of question which I've seen a lot, which can get asked. Which there are two types. Okay, one is equations involving surds you need to know. For example, let me give you a quick example. If you have root 5x equals to root 2x plus root 7, let me write it down for you. Black. Root 5x is equal to root 2x plus root 7, and you have to solve for x. Well, just like every case, you bring the x's to one side. Oh, Shamed, x's. Oh, you shouldn't have reminded me of x. Too bad. So it becomes x multiplied by square root of 5 minus square root of 2 equals to square root of 7. So it can become x is equal to square root of 7 over square root of 5 minus square root of 2. Okay, see, now this is interesting. Here you were saying that one of them will always be a non-square root of number and one of them will be a square root number. No, it's not necessary. I can have root 5 minus root 2. I still have to rationalize it. No problem. I can do root 5 plus root 2 and root 5 plus root 2. This is still a square minus b square. Sorry, a plus b, a minus b, which is a square. Oh, my bad, guys. I just realized I was making a mistake. Okay. I hope the comment section hasn't filled up, or you guys aren't abusing me. This is a square minus b square. I was thinking, something fishy. This is a square minus b square. Okay. So this 1 plus root 2, 1 minus root 2, it will be 1 square minus root 2 square. So this will be 1 minus 2, which is negative 1. So you will get negative 1. So you can write it as, because you want to send the negative to the numerator, so it will become minus 2 plus 2 root 2 over 1. Okay, this is how it will become. It's a square minus b square. Okay, so I'm sorry for that. Let me just check. Am I right? Yes, I'm right. Okay, I got a little bit uh scared there. I'm like, whoa. Okay, so this will be minus 2 plus 2 root 2 over 1, which is the same thing as minus 2 plus 2 root 2. So this case, it will be a plus b, a minus b, a square minus b square. So this will be root 7 times root 5 plus root 2, a square minus b square. So it will be root 5 squared minus, by the way, this is root 2 here, root 5 plus root 2, minus root 2 squared, which is, let's expand here. This will become root 35 because root 7 times 5 plus root 14 over 5 minus 2. This becomes x is equal to root 35 plus root 14 over 3. That's the answer. Okay, the you might have some questions like this, or there's another type of question which I really want to show you guys. Those questions involve triangles. Okay, those questions involve triangles. And also there's actually one more type of question where you might be given a, again, you should practice past year papers for this. But there's one more type of question. You might be given a quadratic equation in terms of surds. So there'll be a lot of complicated algebra there. Like, negative v plus minus square root of v square minus 4ac over 2a. You might have to do that with surds. So that gets complicated there. Okay, but we won't do that much detail. It's not that I'm scared. This is just a revision of the concepts. Okay, not a revision. This is not a revision. Okay, this is a detail of all the main concepts. Those, if you're learning this for the first time also, you can see this. If you're revising this also, you can see this. But you should try questions on your own. Okay, now this is one question which I'm trying with you because I have seen this type of question a lot. Okay, the diagram shows a triangle ABC. In triangle, and A is equal to 90. Sides A, B, and BC are blah, 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 blah. Find tan B. Tan B in the form A plus B root 5. We want to find tangent of this angle. So we know that tan B, so it's opposite over adjacent, right? So it will become AC over AB. So tan B is equal to root 5 minus 1 over root 5 minus 2. Now, by the way, if you put this in your calculator, right? If you put this in your calculator, it will give you 3 plus root 5. But there's the problem. You can't do this because first thing, you need to show your working. There are marks for working. And second thing, this might come out in the non-calculator paper for those who are giving you exams from 2025 onwards. Okay, this might come out in the non-calculator paper or for any of you. This applies to, okay, for the non-calculator paper, it only applies to 2025 and more. For all of you, even if this comes out in a paper where you can use calculator, for which 2024 students can use calculator every time, you still need to show your working. Okay, so this will, you rationalize it using this method. So it will be root 5 plus 2. Okay, so how will this work? This will become root 5 minus 1, root 5 plus 2 over, I'm going to skip a step. I'm going to straight away say 5 square. So root 5 square will be 5, and then minus b square will be minus 2 square, so minus 4. Root 5 square will be 5, and 2 square will be 4. Okay, so this let's write this here. The answer is 3 plus root 5. So if you can still cross check this with the calculator. Okay, you can cross check this with the calculator, but you can't directly solve it using a calculator. And if you're not even allowed a calculator when they ask you the question because of non-calculator paper, then too bad. Okay, that's why I practice more questions of this. So if you foil this, so if I solve this one first, root 5 times root 5, it will be 5. Then this will be 2 root 5, so plus 2 root 5. Minus root 5, so minus root 5 here. Minus 2, so minus root here. Over 1. This becomes 3 plus root 5. Yep. So yeah, that's it for this one. Okay, if you have any specific questions, then please type it in the comments. Okay, and if you feel that you want to learn more, or I really hope these videos are helping you. Okay, I want to help you as much as I can. I want to maintain quality and quantity. Okay, that's why I can't have very long lecture, but I can't have very short also. So because I don't think there's anyone else on YouTube who's doing who's doing the whole chapter in one shot. Okay. And I don't think there's anyone who can do it. I don't think and even if there have been people who've done it, like I've done Add Maths myself. Okay. I did not find anyone who's doing it in one shot. In one shot, I did not find anyone who's doing it. And even if someone is doing it, I don't think they're summarizing it within 30 minutes, within 45 minutes. Okay, the functions one was 45 minutes. So yeah, get as much value from this as you can. Okay, and if you feel you need more value, but hopefully this is enough for you. If you feel you need more value, you need more personalized attention, then I also give tuitions for Add Math, Physics, and Maths. You can check that out in the description. A little bit of self-promotion there. Shamit, I know I see where you're going, self-promotion. Yeah, a little bit of self-promotion, okay? Come on, I'm giving you all the chapters summaries in one shot for free. I deserve a little bit of self-promotion, right? And for some of our friends who are watching this might actually be helpful. You might actually want to know about the tuitions if you want to join. So yeah, you can check that out in the description. If you don't get an A or an A star, you can just get all your money back. That's our policy, okay? We help you, then we earn. If we don't, then both of us. Okay. So if you don't get an A or an A star, you can get all your money back. That's a little bit of self-promotion there. That's almost like a theme, okay? We get rewarded if you get rewarded. If you don't get rewarded, we don't get rewarded. So if you get your A star, we get our rewards in terms of satisfaction and some money. And if you don't get that, then we don't get our rewards for our efforts either. Okay, so yeah, that's it for this class. This is I'll be uploading all the other chapters as well, one shots soon. Okay, soon. But be prepared. Some of them might be a little bit longer. Okay, like differentiation, integration. Those ones can't be done in 30 minutes. I might take 45 minutes for that. I might take 50 minutes for that, but I'll try my best to maintain quality and quantity, as I said. Okay, so not bad. This one was done within 30 minutes. It's been 29 minutes since I've been recording, I think 28, 29 minutes. So yeah, guys, speaking a little bit too much towards the end, but yeah, everyone likes a little bit of talk, right? So yes, guys, that's it. Okay, keep enjoying, keep studying, keep having fun. See you guys. Bye-bye. Take care. Stay safe.